Hi all. In the last class, we have seen some problems on mu and delta. Before that, we have finished the definition of Newton-Gregory formula for equal intervals. So, in that class, we have discussed these two formulas: Newton-Gregory forward interpolation formula and Newton-Gregory backward interpolation formula. So today we start discussing numerical analysis by giving remarks on these definitions. So we will replace this. Can be this f of a plus n times h can be obtained using the values of these f or this 1 plus delta whole raised to n. So in order to find out the values in between the values given in the intervals, suppose we are given 0, 5, 10, 15, 20, 25 are the equal intervals. So if this is the case, 0, 5, 10, 15, 20, 25 are the values, then in order to find out a value of this f at in between this 5 and 10, suppose we have to evaluate the values of this f at 10 at 8, okay, that is in between 5 and 10. So we use the forward interpolation formula, okay. That means if you are given these values 0, 5, 10, 15, 20, 25, so these are the values given, then in order to get the value of this f at 8, that means these are the values of x, then we need to find out f of x when x equal to 8. So now we can say that this x equal to 8 comes in the beginning intervals 0, 5, 5, 10, 10, 15. So using these subintervals we can say that the second interval, this 8 comes from the second interval, okay. So in order to evaluate this f of 8, we compare this f of 8 to this f of a plus nh or f of a minus nh. So if this 8 comes from the first part of this subintervals, so we use forward difference formula, okay, forward interpolation formula to evaluate this f of 8, okay. That means we need to equate, or this we compare this f of 8 with this formula, okay, instead of this. Suppose in order to evaluate the value of f at x equal to some 23 or 17, so we will use this formula, and Newton-Gregory backward interpolation formula. In that at that time we compare, in order to evaluate f of 23 or some f of 17, we compare this quantity with this f of a minus nh, okay. So this is the remark given on this formulas, Newton-Gregory backward and forward interpolation formula. So here the problem is to find or use Newton's forward interpolation formula to find y at x equal to 8. That means f of x at x equal to 8. So we use the Newton's forward interpolation formula. So please note that if a plus nh is near the beginning, use forward interpolation formula. If a minus nh is near the end, use backward interpolation formula. So you need to I'll write this remark here. Remark: if a plus nh is near the beginning, use forward interpolation formula. Next, if a minus nh, if you compare this quantity with a minus nh and a plus nh, if a minus nh is near the end, use backward interpolation formula, okay. Another remark is, for the convenience, we chose the interval of the length of the interval of differencing as 1, or not length, the a should be chosen so that n lies between this -1 and 1. Okay, so we have one more remark on this. Remark: as far as possible, a should be so chosen that n lies between -1 and +1. Okay, so by comparing this 8, first of all we need to 8 we need to compare this 8 to a plus nh. Okay, this a plus nh. Okay. Now you can choose this a in such a way that n should be in between -1 and 1. So here if we choose a is equal to 0, if a equal to 0, we can say that this 8 can be 0 plus nh, and h is 5 here, so we put 5 here. This implies n will be 8 by 5. Okay, that will be 1.6. So we need to choose this a in such a way that n should lie in between -1 and 1. That will give a more accurate value for this f of 8. Okay, so in order to so please note these two remarks. I'll conclude two remarks again. If the value of this x is beginning of the interval, then you choose a plus nh to compare with this 8. Okay, otherwise you take a minus nh to compare this. So by in order to choose the a, you should remember that that n should be in between -1 and +1. Okay, now we can evaluate the function at x equal to 8. So first we write this. Here we have written that n is equal to 1.6, a is equal to 0. Okay, now consider the table. We need to evaluate f of 8. In order to get the f of 8, you need to evaluate this right hand side. To find right hand side, we need to evaluate y0, delta y0, delta square y0, delta cube y0, etc. So first of all we have to evaluate the table, forward difference table. To evaluate this f of 8, you first complete this table. So these are the x values and these are y values. First we evaluate delta y. Delta y is nothing but this 4, that is y2 minus delta y0. So this is our y0, and this is delta y0. This is our delta y0, that is y1 minus y0, and delta y2 will be this y2 minus y1, so that will give 3, and here we have 18 minus 14, that is 4, 24 minus 18, that is 6, and 32 minus 24, that is 8. Now we will evaluate the difference between this delta y1 minus delta y0, that will give delta square y0, so that is 1. This is our delta square y0, and here we have 1 again, and here 2, and here we have 2. Okay, now the difference between these two, delta square y1 minus delta square y0, that will give delta cube y0, that is 0 here. Okay, delta cube this y0, sorry, this will be 4 minus 3, that is 1. Here we have minus 1. This is minus 1 because 3 minus 4, that is minus 1, and this minus this, that will 2, that will be 2. This is 2, and difference between 2 minus 1, that is 1, and 2 minus 2, that is 0. Now delta cube y1 minus delta cube y0, that is delta raised to 4 y0, that is 1 minus 2, that is minus 1, and here we have 0 minus 1, that is again minus 1. Okay, now this the difference between these two will be 0, that is what we have, delta raised to 5 y naught. So first you need to complete this table, then only you can write f of a plus nh. What is f of a plus nh? F of a plus nh is y naught plus n delta y naught plus n into n minus 1 divided by 2 into 2 factorial into delta square y naught. Now we have n into n minus 1 into n minus 2 by 3 factorial delta q y naught. Then we have, so this is the formula for a plus f of a plus nh. Delta raised to 5 y naught will be 0, so we need to we can neglect this term because this is 0, so we need to evaluate all these things. So f of 0 plus this will be 8, so this is nh is equal to 8, n is 1.6 here and h is 5. So please substitute this on the right hand side. So you will get 7, y naught is 7, so here we have 7 and 1.6 times delta y naught, that is 4, plus 1.6 into 0.6, that is n into n minus 1 by 2 factorial is 2 into delta square. Delta square of y naught is minus 1, so this is minus 1 plus n into 1 minus 6 into 0.6 into minus 0.4 divided by 3 factorial times delta q y naught. Delta q y naught is 2 plus n into, that is 1.6 into 0.6 into 0.4 into, so we have, this is 0.4 minus 0.4 into minus 1.4 divided by 4 factorial into delta raised to 4 y naught, that is delta raised to 4 y naught is minus 1, so this is minus 1. Okay, now evaluate or simplify this expression, then you will get, this will be 12.77. So this is correct to 2 decimal places. So this is the value of this is nothing but f of 8. So compare this 8 as 0 plus 1.6 into 5. Now you will get f of 8 will be 12.77. That means if you put 8 here, then the value will be 12.77 approximately. So this is the way we interpolate a value in between 5 and 10. So you can, using these formulas, backward or forward difference formulas, you can find the value, approximate value of interpolating value of any x in between these intervals. So this is illustrated example for this Newton-Gregory forward and backward difference formula. So there are a number of illustrative 5 or 6 or 5 illustrative examples are given in the textbook, so please go through it. In the next we will discuss 22.8, the Lagrange's formula for unequal intervals. So this is the interpolation formula for equal intervals. Lagrange's formula for unequal intervals. This is the formula for the function y equal to f of x. We have the values y0, y1, y2, etc. yn. When x assumes the values x0, x1, x2, etc. xn respectively. If the values of the of x are not at equal intervals, that means the difference between these consecutive numbers x0, x1, x2 are not equal, then we use this formula f of x equal to y0 times y0 is f of x0 in fact times this one x minus x1, x minus x2, etc. x minus xn. So we avoid x minus x0 in the numerator, and in the denominator we avoid x0 minus x0, so that will become 0, so we avoid those numbers. Then plus y1 times, y1 is f of x1, that times this number x minus x0. In the numerator we avoid x minus x1, so the numerator becomes x minus x0, x minus x2, etc. x minus xn. In the denominator we neglect or we delete x1 minus x1 term, so all the other terms will be here. So this is y1 times this number, and this in fact this term a polynomial in x. Okay, the denominators are constant numbers, because these x1, x0, x2, etc. are given, and the only unknown is x here, okay, in the numerator, plus etc. plus yn times this one. Okay, here we avoid x minus xn, in the denominator xn minus xn. Okay, so this is called Lagrange's interpolation formula. So if you are given the values of this y0, y1, y2, etc., yn and x0, x1, x2, etc., xn, using this formula you can evaluate the values of f at any point in between, or any point x belongs to R. So next we will discuss illustrative example. This is the example. Using Lagrange's interpolation formula, find the value of y when x equal to 10 from this table. So these are the values. Here we put x0 is equal to 5, x1 is equal to 6, x2 is equal to 9, and x3 is equal to 11. Okay, here we have y0 is 12, y1 is 13, y2 is 14, and y3 is equal to 16. Okay, so first you observe that this x0, x1, x2, x3 are in equal interval, so this is not. This is 5, 6, the difference is 1 here, but the difference is 3 in this consecutive number 6 and 9. So we can consider these are unequal interval. So we use the Lagrange interpolation formula. If these intervals are these values are at equal intervals, then we can use Newton-Gregory interpolation formula. So in this case we use this Lagrange's formula. So in order to define f of x, we use this formula, f of x equal to y0 times this one. So what is our f of x? So f of x is nothing but y0 times, what is y0 here? Y0 is this 12, y0 is 12 here, that is the first value, and that times we have x minus x1, x minus x2, x minus x3 first. Okay, so that is x minus 6, x minus 9, x minus 11 divided by the denominator becomes x0 minus, x0 is 5 here, so 5 minus 6, 5 minus 6, 5 minus 9, 5 minus 11. Okay, so these are the values. So this will be the first bracket, plus the next is y1 times. Okay, y1 is 13 here, so 13 times this much numbers. Again x minus 5, this is x0, we avoid x1, so the next will be x minus x2, that is x minus 9, and the last term will be x minus 11 divided by, we have this again x1 minus, okay, x1 is 6, so 6 minus 5, 6 minus 9, 6 minus 11, plus now we have y2 is 14, so 14 times this number, this much number, that is 14 times x minus 5, x minus 5, x minus 6, x minus 11, okay, x minus 11 divided by this 9 minus, okay, 9 minus 5, 9 minus 6, 9 minus 11. Okay, finally we have y3 times, y3 is 16 times, the numerator will be x minus 5, that is x minus x0, x minus x1, that is x minus 6, and x minus x2, that is x minus 9, and the denominator we have 11 minus, so this is x3 here, so 11 minus 5 into 11 minus 6 into 11 minus 9. So this is the value of f of x when you use the Lagrange's interpolation formula. So now our intention is to find f of 10. So the value of f at x equal to 10, then what is f of 10? So in order to evaluate f of 10, you need to put 10 in this expression. So when you simplify this, then you can get 12 times 4 times 1 times minus 1 times 1 time divided minus 1 divided by minus 1 minus 4 minus 6. Okay, so this is obtained by putting x equal to 10 in the first term. So that will be 12 times 10 minus 6, that is 4, 10 minus 9, that is 1, 10 minus 11, that is minus 1. Similarly, 5 minus 6, that is minus 1, 5 minus 9, that is minus 4, 5 minus 11 is this one. Okay, plus, and the next term will be 13 times 5, 1, minus 1 divided by 1, minus 3, minus 5. This is from the second term of the previous expression. So putting x equal to 10 here, then 10 minus 5 is 5, 10 minus 9 is 1, 10 minus 11 is minus 1 again. This is 6 minus 5, 6 minus 9, 6 minus 11. Plus we have 14 times, we have 5 times 4 times minus 1 divided by 4 times 3 times minus 2. Okay. So this is from the third term, and finally we have 16 times 5 into 4 into 1 divided by 6 into 5 into 2. This comes from the last term. Okay. When you simplify this, you can get 2 minus 13 by 3 plus 35 by 3 plus 16 by 3. So please verify these numbers from the previous expression. So this is equal to 14 and 2 by 3. So this is the value of f of 10. Okay, so this is the way we use Lagrange's interpolation formula. If the values of x are not in equal intervals, so we can use this formula. Otherwise, we will use a Newton-Gregory backward or forward interpolation formula. Okay, so in the textbook there is one more illustrative example. Please try to work it out. And if you have any doubt, please come up with your doubt. We can discuss. Section 22.9, Central Difference Interpolation Formula. In this section, the first central difference interpolation formula is Gauss forward interpolation formula. So that is given by y of p is equal to y naught plus p times delta y naught plus p times p minus 1 divided by 2 factorial delta square y minus 1 p plus 1 p into p minus 1 divided by 3 factorial times delta q y minus 1 plus etc. So this is the way we evaluate or interpolate the value of y at x. So here this p is x minus x naught divided by h, where this x is the value to be interpolated. Now we have how to identify this formula for the beyond this fifth degree term. So for this we need to follow a rule, or you need to remember this fact. I write this is y naught and this is our delta y naught, and we write all the differences, all differences of y minus 1 with all orders. So this will be square, and this is delta square y minus 2 delta raised to this is raised to 4 5 minus 1, this is delta raised to 4 y minus 2. I'll write it as delta raised to 4 y minus 2 delta raised to 6 y minus 3. Write all the even powers here. Delta raised to 8 minus y minus 4 here, and etc. So this is what we call the center line, and this is the way we remember this formula. That's the thing. This is delta y naught. Here we write again delta y minus 1, delta y minus 2, delta y minus 3, etc. with the power 1, 3 and 5. Here we have delta y, this is y minus 1, 2, 3 and 1 is already here. The first power term is already there. So this is our 5 and this is 7 this is 7, and this is 9, etc. So we have written y minus 1, delta y minus 1, delta y minus 2, delta y minus 3, delta y minus 4, etc. in the center line, what we call, this is our center line. Now this is center line, we call this as our center line, and this is the line below the center line. Okay, so we write this formula using y naught. This is y naught, the first term is here, and for the second time we write p times delta y naught. So we move on to this way, p times delta y naught. Then again we move on to this way. So from this on the second term we have delta square of y minus 1 with p into p minus 1 by 2 factorial. Okay, so we add one more term in the numerator compared to the first term, so that is p minus 1. Since there are two terms, then we have 2 factorial here. Again we come to the below line, that is delta cube y minus 1, that is in the third term with p into p minus 1 we add one more term, p plus 1 in the left with 3 factorial, okay, in the denominator. Now we move on to this way. Okay, that is the fourth term. Then we move on, then we add one more term, p minus 2 in the numerator, then divided by 4 factorial, since there are four terms in the numerator, and we take this term. Now we come to below line, that is delta raised to 5 of y minus 2, so that is this term. Then at that time we add one more term to this, p plus 2 in the left side, that is p plus 2, p minus 1, p minus 1, p minus 1, p minus 2 divided by factorial 5 times delta raised to 5. Then the next term we can write the next term as this one, that is we need to add one more term to the right. From this we add one more term to the left, and we write one more term, so that will be p plus 2, p plus 1, p minus 1, p minus 2, and p minus 3. This is the one more term. So since there are 6 terms, we have 6 factorial. Here we will write this delta raised to 6 y minus 3. Okay, then plus the next term contains delta raised to 7 y minus 3, so that with this p plus 3 term, p plus 3, p plus 2, etc. Okay, so this is the way we write this formula. So this is what we call Gauss interpolation formula. Next we will explain one example to illustrate this formula. This is the example. Using Gauss forward interpolation formula, find the value of log 337.5 from the table. So this is the table. These are the x values: 310, 320, 330, 340, 350, 360. Then y values are this. So we need to find out the value of this y at x equal to 337.5. So this is our x, and that comes in between 330 and 340, so somewhere here. So this is our x value, 337.5. So how do you evaluate the y value at this point? Okay, so in order to evaluate this, or not to use the Gauss forward interpolation formula, we put x naught is the value given in this table just before this 337.5. So that is going to be 330. So this we set x naught is equal to 330. Now you defined p. P is our x minus 330 divided by 10. 10 is the interval of differencing. This is 310, 320, 330, 340, 350, 360. So the interval of differencing is equal, then that is 10. So p is to be defined as x minus 330 divided by 10. Okay, since our h is equal to 10. Okay, now we construct the table, the forward difference table. From that we can collect the values y minus 1, delta square y minus 1, delta q y minus 1, etc. So first we construct those Newton forward difference table first. Okay, this is our table. These are the x values. Then we evaluate p values for these x values. If x equal to 310, then first of all we write if x equal to 330, then the p value is 0, because 330 minus 330 divided by 10, that will be 0. And if x is 340, then p value is 1, and 350 p value is 2, 360 p value is 3, and for 320 the p value is minus 1, because this is 320 minus 330 divided by 10, so that is minus 1. Similarly, this is minus 2. Okay, now these are the delta. This is yp's. Yp's are the values given in the table. So that is 2.4914. This is 2.5051, 2.5185, 2.5315, 2.5441, 2.5563. Okay, so these are the y values. Now the delta yp. So delta yp is the difference, the forward difference, this minus this. So 2.5051 minus this is equal to 0. Here we have 0.10137. Now we have this value is 2, so question we have 2 here, so we have 2, then this is 8, then the next value, the delta yp, that is this minus this number, so that will be again 0.0133. Here we have 0.0130, this is 0.0126, and this difference is 0.0122. Okay, so these are the delta yp's. Now we have that means delta y minus 2 is this one, delta y minus 1 is this one, delta y naught is this one, delta y1 is this, delta y2 is this. Okay, so this is the delta yp. The delta square yp will be this minus this one. Okay, so that is the difference between these two. So we have negative 0.0005, and the difference between this is negative 0.0003, and difference between these two will be negative 0.0004. This is again negative 0.0004. Okay, so these are the second order differencing, and third order differencing will be the difference between these two, that will be 0.0002, and this between this is minus 0.0001, and difference between these two, that is 0, so 0.000, because both the values are the same. And we have fourth order difference. Fourth order difference between this minus this, so this minus of minus this one, that will be 0.0003 minus, so this is this minus this, sorry, this is 0.002. The difference of this value is this minus this one. Okay, so this is obtained by minus 0.0001 minus 0.002, not this from this, because this negative number minus this number. Okay, that will be minus 0.003, and this minus this. Okay, so that will be plus 0.0001. Okay, so 0 minus of this quantity. Now we have difference between this minus this, so that is again plus, that is 0.0004. so these are the differentiation table or forward difference table to evaluate this formula. Now we evaluate this one. Okay, so in order to evaluate this formula, we need to get y naught first. Okay, y naught is the image of x naught. Okay, we have said this x naught is 330, so this is our y naught. Y naught is the value, this 2.5185. so I said this is our y naught. Okay, to the form to this formula we set y naught as this, because this is our x naught. we take this as our x naught, so and y naught is this one. Okay, now we need to get the second term. We need to get delta square y minus 1. Okay, so delta square y minus 1 is minus this is our y minus 1, this is y minus 1. So delta y minus 1 is this one. Okay, and that is delta y minus 1 can be obtained from this minus this. Okay, so that is this one. This is delta y minus 1. So delta of delta y minus 1 is delta square y minus 1. So this is our delta y minus 1, and this is delta of this, that is this minus this, so that will give delta square y minus 1, that is this number. Similarly, so our required values are, we need to take this value. Okay, and next we will take the value. So this one, the second time we have delta y naught. So delta y naught is this value, this delta y naught, this is in the second term. Okay, so we come to this way, and we will take this one, delta square y minus 1, that is in the third term. In the fourth term we have delta raised to 4 y minus 2. Okay, so we need to take y minus 2. So this is our y minus 2, this is x minus 2, this is x minus 1. So this is our y minus 2. Okay, and this is our delta y minus 2, and this is our delta square y minus 2, and this is our delta cube y minus 2. Now we have this value, this is our delta raised to 4 y minus 2. So we need to take this value as well. Okay, so before that we have delta cube y minus 1. So we before that we need to take this delta cube. We have this is for the first term. I'll write it here. So this is for the first term, and this is for the second term, that is delta y naught. For the third term we will collect this, that is delta square y minus 1 and delta cube y minus 1. So that is, this is delta cube y minus 1. We need to collect this also. So this is for the fourth term, so that is delta cube y minus 1. And for the fifth term, this is our fifth term, starting from this 1 2 3 4 5, fifth term, that is fourth order term. Fourth order term we need to collect delta raised to 4 y minus 2, that is this one. And for the last term we will collect delta raised to 5 y minus 2, that is this one, delta raised to 5 y minus 2, that is this value. Okay, so first we take y naught for the first term, second term we have delta y naught, third term we have delta square y minus 1, and the fourth term we have this. For the fifth term we will take this term, and sixth, the last term, the sixth term we will collect this. Okay, using these values we will evaluate the y of yp, that is yp, that is going to be f of, that is log 337.5. So for this we have said this x naught is this one, and if x equal to 337.5, in this case what is p? In that case p is 337.5 divided minus 330 divided by 10, then that will be 0.75. This is 0.75. Now y naught, what is y naught? Y naught is our 2.5185. So this is we have the formula. This is the formula. We write a formula y naught plus p times delta y naught. So first term is y naught is, we will write the formula again, y naught plus p times delta y naught plus p minus 1 divided by 2 factorial delta square y minus 1 plus p plus 1 p minus 1 by 3 factorial delta cube y minus 1 plus p plus 1 p minus 1 into p minus 2 divided by 4 factorial into delta raised to 4 y minus 2. The last time we have p plus 2 p plus 1 p minus 1 p minus 2 divided by 5 factorial delta raised to 5 y minus 2 plus x. Here we have only this much step, so this is the value of this. Okay, now we substitute for this y naught. What is y naught? Y naught is 2.5185 plus what is p? P is 0.75, and what is the value of this? Delta y naught. Okay, so we have written what is delta y naught here. Delta y naught is 0.0130. Okay, so that is the second term. For the third term we have 0.75, that is p, then p minus 1. Okay, that is this number minus 1. So 0.75 minus 1 divided by 2 factorial delta square y minus 1, that is this one. Delta square y minus 1 is this one, 0 minus 0.0003, and now we have the fourth term. Fourth term is this one, that is plus p plus 1, that is 0.75 plus 1, then 0.75, then 0.75 minus 1 divided by 3 factorial delta q y minus 1. Okay, so that is this one. Delta q y minus 1 is this one, that is minus 0.001. okay, plus the fourth term will be this number into, that is 0.75 plus 1, 0.75, 0.75 minus 1, 0.75 minus 2 divided by 4 factorial into this number. Okay, delta raised to 4 y minus 2, so that is minus 0.0003. okay, finally we have the sixth term, that start from p plus 2 into. Okay, so what is p? 0.75 plus 2, 0.75 plus 1, then 0.75, then 0.75 minus 1, 0.75 minus 2 divided by 5 factorial into delta raised to 5 y minus 2, that is this one. Delta raised to 5 y minus 2 is 0.0004. okay, now you simplify this expression, and you will get this as 2.5282. okay, so this is the value of this. Then we can set log 337.5 equal to 2.5283. so this is the way we use Gauss forward interpolation formula. Thank you. The next class we will discuss another central difference interpolation called Gauss backward interpolation formula. Thank you.